Hello everyone. Let's begin today's lecture that is based on motion and time. As you all know that it is the third lecture. In the previous lecture we have discussed about the different types of motion, and as well as we have also discussed the speed, how to measure the speed and the units of speed. In this lecture we will discuss about measuring time, simple pendulum, components of simple pendulum, and some factors which are related with the simple pendulum. All these factors like oscillation, time period, frequency, these things we will discuss in this lecture. So get ready to know something new today. Let's start. First of all, measuring time. How do we measure time? We used to measure the time for by using the clocks and watches. Clear? The clocks and watches makes the use of periodic motion. The periodic motion we have discussed already. So all the clocks and watches are based on the theory of periodic motion, and we used to measure the time with the help of these types of the clocks. You can see into the picture there are the different types of the clocks like wall clock, table clock, watches, digital clock. We also use nowadays the mobile phones, which is also a different form of the digital clock. So these are the different types of the clocks and watch which we use to measure the time. But have you ever thought that into the ancient time, when the digital clock was, or the clocks and watches are not made, how did the people measure the time? They used to they use the different some other types of the instrument for measuring time. These instruments were sundial, water clock, and sand clock. Okay, these instruments are used to measure the time. Clear? Now the next topic, that is simple pendulum. It is the important topic. So let's come to know that what is simple pendulum. As you can see into the picture, there is a stand by this stand a thread and a mass is held. Okay, the thread containing the mass is here holding on the stand. So these kind of system is known as simple pendulum. So let's come to know about the more about the simple pendulum. The question is, who discovered the simple pendulum? It is discovered by the Galileo Galilei. He was an Italian scientist and he studied about the different properties of simple pendulum. Whatever the properties of the simple pendulum along with the factors related to the simple pendulum, that we also discuss into the lecture. Clear? So what is the simple pendulum? Definition of simple pendulum, if we talk about, it is an ideal pendulum. Student, just see here, ideal term is given. So an ideal pendulum consisting of a point mass suspended by a weightless, inextensible, perfectly flexible thread and free to vibrate without friction. Here some important points are given. I just want to pay your attention here, like inflexible, weightless, and inextensible, weightless, perfectly flexible, along with that frictions. So these are the factors. Means if this kind of system is created, it is known as the ideal pendulum. But into the laboratory it is not possible to create the pendulum like which contains the weightless thread, because every thread has the weight as well as inextensible and perfectly flexible. The another factor that is also here, that it should be frictionless. There will be no friction. So if we create the simple pendulum into the lab, there is the friction generated by air will be there. So it is not possible to make the simple pendulum, an ideal simple pendulum, into the laboratory. But if we create the vacuum and we use the weightless and stainless thread, it may possible to make the simple pendulum. So it is the complete definition of the simple pendulum. Now the next thing is parts of the simple pendulum. So parts of the simple pendulum: length and mass of the bob. As I have told you that it is made up of, it is a mass of the bob. A mass is held on the thread. So what is length and what is mass of the bob, that we discuss also. The length of the simple pendulum is the distance between the point at which it is hung from the stand and the center of the bob. You can see here that it is a thread which is just tied on a fixed point, along with that the bob also. So the distance from the fixed point till the bob is known as the length of the simple pendulum. It is, you can also say that it is the length of the thread. Clear? Now, mass of the bob. We can use the metal as the bob. As you all know that at the at another end of the thread there is a mass which contains the there is a bob which contains the weight is hanged. This is the spherical structure, and this is made up of any kind of metal. So this is the, it is the means the spherical structure which is made up of any metal which contains the weight or mass is known as bob. Now, what are the factors of simple pendulum? So there are the different factors which are related to the simple pendulum, like oscillations, equilibrium position, amplitude, periods and frequency, time period and frequency. So these things we will discuss one by one. So let's start. Some oscillation. Students, if you recall the oscillatory motion, I have told you that this is the oscillation, or the oscillatory motion is a type of motion in which any object just move to and fro motion and repeats its path. So if we are going to define the oscillation, it is the to and fro motion of the pendulum about a fixed point. As you can see that this is the just the diagram of the pendulum. It is just at the fixed point. The fixed point is given here. Suppose that we have written the name of the fixed point is P. When we just move the simple pendulum from by holding its bob, it starts to move in this way. Clear? So if we are talking about the oscillation, we can say that it is just showing a to and then fro motion, to and fro motion, to and fro motion. In this way it is showing a to and fro motion. Along with that, it is also repeating its path. You can see that it is also repeating its path. So this type of motion is known as oscillation. But if we are talking about one oscillation, what is one oscillation? So the movement of the bob from its mean point or equilibrium point. Mean point means O. Okay, from its mean point, if it moves to the one extreme end and then again to its mean point and then again another extreme end and then again to its mean point, means this complete movement of the bob is known as one oscillation. Clear? Don't be confused. Again, I'm repeating that one oscillation means from mean positions to one extreme end, other again mean position, then again another extreme end, and then again to the mean position. This is known as one oscillation. Okay. Now the bob completes one oscillation when it swings from O to B, then to A, and then it returns to O. Again the same thing is that if it moves from O to B, then again B to A, and then again to O. This will be the complete one oscillation. Clear? Now equilibrium position. What is equilibrium position? When pendulum is at rest, it is said to be in equilibrium. Equilibrium position means when the pendulum is just held on O position. When it will be on rest, it will be at the position O. So the position O is known as its equilibrium position, and the pendulum is said to be as it is in equilibrium. Clear? When it starts to move, it makes an arc like structure, and it makes the arc and starts to move. The position of O is equilibrium here, and it start to move, then it show the oscillation. Now, what is amplitude? The maximum displacement of the bob from the equilibrium position is its amplitude. Clear? This is the equilibrium position that we have already discussed. If the displacement start, suppose that this is the another end. So if the bob starts to move to the one extreme end, suppose it is showing the movement till here, this complete distance is known as amplitude. Clear? It may be into the this way also. If the complete if it travels the distance from the mean equilibrium position or mean position to the extreme end, this distance is known as amplitude. So we can say that the maximum displacement from its mean position in this diagram, the amplitude is the distance. This distance is known as amplitude. This distance is known as amplitude because it is traveling the maximum displacement, showing the maximum displacement from equilibrium position to this position. Clear? Again I'm repeating, the maximum displacement of the bob from its mean position or equilibrium position is known as its amplitude. Now the next one is period or time period. We can say that the time taken for completing one oscillation is known as its time period. As I have told you that suppose that this is the simple pendulum. Okay, if it is showing one oscillation and then again two oscillation and then again three oscillation in this way, so the time taken for one oscillation is one oscillation. In completing one oscillation, whatever the time is taken, this is known as time period. Clear? For the time taken for completion of one oscillation again I am telling you that from equilibrium to its amplitude, again this complete movement is known as one oscillation, and whatever time is taken to complete this one oscillation is known as time period. Clear? So if we are going to define the formula of time period, so it will be the time taken for the oscillation upon number of oscillation. Whatever the time taken upon the number of oscillations, suppose it is taking 2 seconds to complete one oscillation, the time period will be 2. Clear? Now frequency. What is frequency? The frequency is the number of oscillations in per second. Clear? Suppose that this is the simple pendulum. Okay, now if we are talking about the frequency, see there is a very difference between the frequency and time period. Let it you have to you don't be confused about that. Frequency means the number of oscillations in 1 second. Clear? Whatever the numbers of oscillation can be done into the 1 second, that is known as frequency. For example, I am telling you, suppose that this is one oscillation. This one oscillation, the time taken to complete this one oscillation is known as time period. But if this simple pendulum covers two oscillation in 1 second, okay, two oscillation in 1 second, in this way the frequency will be 2. So the formula number of oscillation upon time is given already, that is 1. The number of oscillation 2 and time is in 1 second, that is known as frequency. Clear? Again I am repeating that suppose a simple pendulum shows 3 oscillations in 1 second, the frequency will be number of oscillation 3 upon time 1 second is equal to 3. So this is the formula for calculating the frequency. Clear? Now what is the relationship between the time period and frequency? As I told you that time period is equal to time taken upon number of oscillation and frequency is equal to number of oscillation upon time taken. Both are reciprocal to each other. So in this way, if we are going to stabilize any relationship between time period and frequency, we can say that time period is equal to 1 upon frequency or frequency is equal to 1 upon time period. Clear? These both are reciprocally related to each other. Means in other term we can say that if time period will increase, frequency will decrease, or if frequency will increase, time period will decrease. Clear? So this is the simple relationship between the time period and frequency. Now here are some examples of simple pendulum is given. You can see that this is the simple pendulum clock, swing, and this is also a type of swing. So these three examples showing the movement, just example of the simple pendulum. In this way they show the to and fro motion, and it also repeats its path. So these are known as the simple pendulum, but they are not an ideal simple pendulum. Clear? So students, this is all about today's lecture. Hope you understood all the things, and if you have any confusion, again you can just note down and you can ask into the doubt clearing class. And till then, learn all the things. Try to solve the numerical questions based on the value, to find the value of time period, frequencies, oscillations, and relationship based on the frequency and time period. So just find questions, more and more questions based on this numerical problem, and solve it. Until then, have a good day. Thank you.